When we think about the cloud or like artificial intelligence, there is this almost universal expectation of weightlessness.
Oh, absolutely. Yeah, we've been conditioned for years to think of digital tech as something that just exists above us.
Right, like it's completely disconnected from the physical world. You just type a prompt into your phone or ask a complex question, and the answer just kind of materializes out of the digital ether in seconds.
Exactly.
Yeah.
It feels like magic, but it's definitely not.
Okay, let's unpack this, because our mission today is to totally shatter that illusion for you.
We really are.
We're doing a deep dive into this fascinating July 2026 article by Aaron Rose. It's from Tech Reader magazine, and it's titled Why AI Runs on Cement, Water, and Electricity.
Yeah, and the thesis here is just a massive industrial reality check.
It really is, because the infrastructure footprint we are looking at is staggering. I mean, it is massive, it is heavy, and it is very, very physical.
Right, and right now, public discourse is heavily focused on like which AI model is smarter or, whether they should be open source or closed source.
Right, the software side.
Exactly.
Mm.
Almost nobody is looking at the physical strain these machines are putting on the real world. I mean, every single one of these advanced models relies on power grids, water supplies, construction materials, all being stretched to their absolute limits.
Yeah, when most of us picture AI, we picture, lines of code.
Mm-hmm.
But what we should be picturing is a warehouse the size of multiple football fields, just packed to the brim with servers humming constantly.
That is the reality.
So by the end of this deep dive, I promise that you are never going to look at your local utility bills or like a nearby construction site the exact same way again.
No, you really won't.
Yeah.
And to actually grasp the physical weight of this so-called cloud, we have to start at the foundational level, which is energy.
Right, electricity.
Yeah, the immense amount of electricity required just to keep these AI brains thinking is entirely rewriting the rules of utility planning right now.
It's wild. According to the article, a single large-scale data center can consume as much power as 50,000 homes.
Yeah.
I mean, let that sink in. 50,000 homes. And there are hundreds of these mega facilities currently being planned and built globally.
It's unprecedented demand.
But wait, I have to play devil's advocate for a second here, because data centers have existed for decades, right?
Sure, yeah.
And we also had that massive crypto mining boom not too long ago. So is AI really that much worse, or is this just, standard tech scaling?
What's fascinating here is the fundamental shift in how the hardware actually operates.
Okay, how so?
Well, traditional data centers basically acted as digital filing cabinets. You ask for a website or a video, it finds the file, sends it to you, and goes back to a low-power idle state.
Right, it's just fetching things.
Exactly. And crypto mining, well, that was intense, sure, but it was performing a very specific, narrow cryptographic function. AI data centers are entirely different beasts.
Because they're actually generating the content.
Yes. They aren't retrieving data. They are calculating continuously. Every time a generative AI writes an email or creates an image, it's performing billions upon billions of complex mathematical operations.
Wow.
And that requires specialized chips, specifically GPUs, running at near maximum capacity constantly. So a traditional server rack might draw, say, 5 to 10 kilowatts of power.
Okay.
An AI server rack can draw 40 to 100 kilowatts.
Jeez.
Yeah, it is an exponential leap in energy density.
It's like the tech industry just decided to buy a global fleet of hypercars, but completely forgot to check if anyone had built enough gas stations first.
That is a perfect way to put it.
They're just revving the engines in the driveway, waiting for the fuel, because, as the source points out, our power grids were never designed for this level of sudden, massive demand.
Not at all. I mean, the tech sector operates on a timeline of months. They want to roll out new models, update software, and build facilities instantly.
Right, move fast and break things.
Exactly. But utility companies operate on timelines of decades. Upgrading transmission lines or building a new substation that requires years of planning, environmental reviews, and physical construction.
So when those two timelines collide, you get massive friction.
Massive.
So what does this all mean for the grid when utility companies literally have to tell billion-dollar tech companies to wait in line for years just to get plugged in?
Well, it creates a massive bottleneck, and it forces grid operators into a corner. They're suddenly having to forecast power demands that just totally dwarf their historical models.
I can imagine.
In some regions, they're having to overhaul their entire long-term infrastructure strategy. Sometimes they're even keeping older, less efficient power plants online longer than planned just to meet this sudden AI baseload.
Wow, just to keep the lights on.
Yeah. The grid simply cannot adapt as fast as the AI industry wants to grow.
And pushing that much electricity, literally enough to power a small city through thousands of tightly packed servers, doesn't just strain the grid.
No, it doesn't.
It creates an incredible amount of physical friction and heat. And dealing with that heat logically pushes us into a quieter but arguably more surprising resource crisis.
Water.
Yeah.
If you have thousands of GPUs running red hot processing those billions of calculations, you have to extract that heat before the silicon literally melts down.
You can't just set up a box fan.
No, you cannot just use standard fans.
The Tech Reader article points out that the most common way to manage that intense heat in these massive data centers is through evaporative cooling.
Right. So instead of mechanical chillers, which act like massive energy-hungry refrigerators, these facilities often use evaporative systems.
How does that work exactly?
They run hot server exhaust through massive water-soaked matrices. It relies on the phase change of water to absorb the heat.
Okay.
It is a highly energy-efficient process, which is crucial because, they're already maxing out their electrical draw. But the catch is, it's incredibly water-intensive.
Wait, I just have to stop you there. We are building the most advanced technology in human history to simulate human reasoning. And our grand engineering solution to keep this cutting-edge miracle from melting is essentially making the buildings sweat.
Yes, it is industrial-scale sweating.
That is hilarious.
I mean, the trade-off they're making is efficiency for volume. By using water to absorb the heat, they save on the electricity they desperately need for the servers themselves.
Right.
But the volume of water they sacrifice to evaporation in the process is just staggering.
It really is.
Yeah.
The source material notes that a single large facility utilizing this method can consume millions of gallons of water every single month.
Millions.
Millions. And here is the part that highlights the sheer absurdity of the situation. A lot of this is happening in heavily water-stressed regions like the American Southwest.
Oh, yeah.
We are taking the most water-intensive infrastructure imaginable and placing giant, sweating buildings right in the middle of the desert.
It sounds crazy when you say it out loud, but if we connect this to the bigger picture, this is where the AI growth stops being a purely technological issue and becomes a profound municipal resource conflict.
Totally.
In the Southwest, water is a finite, highly contested asset. When a data center moves in and starts drawing millions of gallons a month, that water is being pulled from the exact same reservoirs, aquifers, and municipal supplies that local communities rely on for drinking water.
And farming. Right.
Exactly. It is the same water that local farmers rely on for agriculture.
You literally have AI infrastructure stepping into the ring and going head-to-head with the community's basic survival needs.
Yes.
The article actually mentions that municipalities are already starting to push back. Local governments are looking at these proposals and realizing they literally do not have the water to spare, no matter how much tax revenue or prestige the facility promises.
And it forces a very uncomfortable conversation about priorities. Municipal leaders and utility boards are having to weigh the economic benefits of hosting an AI hub against the basic biological and agricultural needs of their region.
Right.
A faster language model does not inherently offset a destabilized local water supply.
No, it definitely doesn't. But keeping these servers cool isn't just about drawing water, right? It's about the massive physical footprint required to house these specialized cooling systems and heavy server racks in the first place.
Oh, absolutely.
You can't just take these water-cooled supercomputers and plug them into a standard suburban office building.
No, building a modern AI data center is a highly specialized physical undertaking. These structures require vast amounts of reinforced concrete just for the foundations, specifically to support the staggering equipment density we talked about earlier.
Because the racks are so heavy.
Exactly. You have racks of GPUs that weigh thousands of pounds, requiring massive structural steel support. Then you add in the weight of the spiralized liquid cooling manifolds, the heavy-duty backup battery arrays required to prevent grid surges, and industrial-scale HVAC systems. It's a massive construction project.
Here's where it gets really interesting. We have spent the last couple of decades completely separating the digital tech economy from the traditional blue-collar physical economy.
That's very true.
We talk about Silicon Valley software engineers and local construction workers as if they exist in two entirely different universes. But the ultimate digital technology, artificial intelligence, is currently triggering a massive traditional heavy industry construction boom.
It really is. The AI boom is actively disrupting the heavy industry supply chain. The sheer pace of this AI-driven construction is creating intense, immediate pressure on raw materials and skilled labor across multiple markets.
Because they're buying up everything.
Yeah. Tech companies aren't just buying up servers. They're buying up commercial power transformers, specialized electrical switchgear, structural steel, and miles of copper wiring.
And the article stresses that this is not some theoretical future problem. Contractors and developers are feeling this pain right now.
Today.
Yeah. It's showing up immediately in delayed project timelines and skyrocketing costs for building materials. Like if you are a developer trying to build a new hospital or a school or an apartment complex, you are now directly competing for cement, steel, and commercial electricians with trillion-dollar tech companies that have a desperate need to build data centers yesterday.
And they have the capital to outbid almost anyone else for those materials and that labor.
Yeah, they have endless pockets.
Right. And you can't just order a massive industrial power transformer on short notice. The wait lists for that kind of specialized electrical equipment are stretching into years.
Yeah, years. Wow.
Yeah. When big tech decides to build hundreds of these massive facilities simultaneously, they essentially vacuum up all the available industrial resources in a given region.
Okay, so we've been looking at the strain on electricity, the drain on water, and the massive consumption of steel and cement as like individual issues. But the true scale of this crisis only really comes into focus when you realize how these forces interact. The article calls this the convergence problem.
Yeah, because they are hitting simultaneously in the exact same locations, driven by the exact same surge of investment. What is critical to understand is the economic and physical feedback loop this creates.
Okay, unpack that feedback loop for us.
Well, you cannot dramatically impact one of these local systems without destabilizing the others.
Because, like, you can't just drain a municipal water supply without it affecting other systems.
Exactly. Take the American Southwest as a perfect example of this convergence. If a cluster of AI data centers draws heavily on local reservoirs to feed their evaporative cooling systems, the water levels in those reservoirs drop.
Makes sense.
But in many of those regions, those exact same reservoirs are used for hydroelectric power generation. Right. So lower water levels mean reduced hydroelectric output, which in turn exacerbates the electricity shortage caused by the exact same data centers pulling immense power from the grid.
That is a brutal, vicious cycle.
It really is.
I mean, just put yourself in the shoes of a local mayor for a second. Imagine a major tech company comes to you. They offer you the prestige of hosting a cutting-edge AI data center.
Sounds great on paper.
Right. They promise tech jobs. They promise your town will be a hub for the future. But the reality is, saying yes means this facility will simultaneously drain your town's power grid to the brink of blackouts, it will deplete your local reservoir in the middle of a drought, and it will monopolize all your local construction labor, driving up building and housing costs for your residents. Like, what do you do?
Well, this raises an important question about transparency, because the technology industry has been incredibly slow to publicly reckon with this multi-pronged strain on local infrastructure.
Yeah, they don't really talk about it.
No. They are aggressively accelerating the very investments that are causing these feedback loops, while largely keeping the public relations focus strictly on the software side. You know, the magic of the cloud.
Right, the weightlessness.
Exactly. They are leaving local mayors, city councils, and utility boards to untangle the physical fallout.
It demands that we start thinking critically about how we balance things. We really have to balance the aggressive acceleration of AI development with the very real, very finite limits of local physical infrastructure.
We do. Because the Earth simply cannot support an infinite scaling of these physical facilities without severe consequences for the people living near them.
So what does this all mean for you listening right now? The core lesson here is that the machines that run these incredible AI models are very much on the ground, and the ground is starting to notice.
Absolutely.
The physical weight of the digital world is landing in our backyards.
The digital economy and the physical economy are permanently linked.
Yeah. If you pay a monthly electricity bill, if you live near a river or a reservoir, or if you are simply watching local housing and construction costs rise in your area, this is not an abstract story about code in Silicon Valley.
No, it's a local story.
The infrastructure demands of the AI revolution are directly reshaping your local economy, your local utility planning, and resource policies in ways that will literally take us years to fully comprehend. AI is affecting your daily life right now, even if you never use an AI product.
It's so true. But, as massive as this physical footprint of water, power, and cement is, there is an entire other layer to this physical reality that the article leaves us with to mull over.
Oh.
Yeah, we've talked extensively about the buildings that house the servers, the water that cools them, and the grid that powers them. But what about the actual brains of the operation?
You mean the AI chips themselves?
Exactly. These highly specialized chips,
Hmm.
the hardware that actually performs the billions of calculations, rely entirely on rare earth minerals.
Right.
And these minerals are mined in only a handful of countries around the world, often under complex supply chain conditions that most consumers never see.
Wow. What?
So it leaves you with a lingering thought.
Yeah.
If building a single data center is enough to severely strain a local United States power grid and deplete a municipal water supply, what happens to global geopolitics when the fragile international supply chain for the physical chips themselves gets squeezed by this exact same massive surge in demand?
Wait, really? That is, wow. The stakes go from local municipal pushback to international geopolitical tension very, very
Yeah,
quickly.
absolutely do.
The physical costs just keep scaling up, from your local water bill all the way to global supply chains. Well, we want to thank you for taking this deep dive with us today. It is so important to keep questioning the physical cost of our digital convenience. We have to look past the illusion of the cloud and see the concrete, the steel, and the water holding it all up. Until next time, keep looking for the physical footprint behind the digital magic.